Students, today we are to discuss the next concept, that is displacement work. In the previous class we discussed that what is thermodynamic work and the work done, example, all things we have discussed, and what are sign convention for work and it. Okay, now we have to discuss that displacement work. Displacement work. Okay, for this here we have to find what is the work done. Okay, for this here consider the piston and cylinder arrangement. Okay, let P1 V1 be the initial pressure and volume, okay, of the gas in the system. P2 V2 be the final pressure volume of the gas in the system. Okay, this is a PV diagram. P can be plotted along y-axis, volume can be plotted along x-axis. V1 be the initial volume, V2 be the final volume. Okay, this is the in general caustic process. How we have to write that? Okay, consider system which contains what? Cylinder filled with gas. Okay, this is a system. Okay, cylinder, that cylinder is filled with what? Gas. Okay, now when piston move outward, okay, when this here, this is a piston, when this piston move from initial place to final place, that is P1 to P2, okay, when it moves, it will start that with some distance, that is displacement, that's here. Let the piston moves outward through a small distance dx in time the interval dt. When gas exert that pressure on the piston, automatically piston move from P1 to P2. Okay, means here small displacement can be happen. Okay, therefore here, since the piston moves only a small distance, the pressure acting on the face of the piston can be assumed constant. Okay, here pressure whatever applied, we have to make that constant. Now see here, from P1 to P2, check that pressure increases or decreases from 1 to 2. Okay, while pressure decrease, volumes here increase from V1 to V2. Okay, now from that we have to find the work. Before that work, how to write that work? Work equal to, already told that the definition means force into displacement. Okay, force means what here? Force means, you know that pressure equal to what? Force per area. Therefore force equal to what? Pressure into area. That is, therefore force equal to what? P into area of the piston. Okay, means piston displaced. Okay, into displacement you have to write here. Displaced distance moved by the piston. Delta W means this is your work, we have to find that only. Okay, this equal to P into area of the piston means you have to take A into what is, how much the distance moved by the piston, that means into dx. Okay, distance. Okay, therefore delta W equal to P into area into volume, that is dV. Okay, that is area into distance means we call that is volume. P into dV, that is A into dx means that is dV, that is volume. Okay, this is in general work done equal to P dV. If the piston moves through a finite, this is infinite distance. Now if the piston moves through a finite distance, when you have to consider finite distance, at the time work done by the piston is what happened? Finite distance means from state 1 to 2. Okay, from state 1 to 2 what you have to write? Work done 1 to 2, delta W equal to 1 to 2. Work done is P dV. Already here we have to derive here. Integration of 1 to 2 P dV means state from 1 to 2 P dV, that is equal to work done 1 to 2. Similarly, if the process proceeds from state 2 to 1, what you have to write? Exactly opposite, that is W2 to 1 equal to integration of 2 to 1 delta W. Same, integration of 2 to 1 P dV. In first process 1 to 2 you have to take on, in second process 2 to 1. Okay, this is in general work done. Displacement work, just you have to write here. Consider the piston arrangement. Inside this gas can be present. Consider cylinder. In that cylinder, what that gas can be present. Okay, let P1 V1 be the initial pressure volume, P2 V2 be the final pressure volume. Okay, when the piston move from initial to final, it causes some displacement. Due to displacement, you have to, that work can be done. Work means what? Work equal to force into displacement. Okay, finally you got delta W equal to P dV. This is work done, that is displacement work. Next we have to find what is the, we have to find work, we have to say that work is a path function. Why you have to say work is a path function means, here process initial state means point A, final state means point B. Process 1 2 3, how many process? 1 2 3. I want to move from A to B. How many ways? That is 3 ways. 1 2 3. Okay, for that reason here consider the PV diagram. P means along axis, volume means along x axis, that can be shown in the figure. It is possible to reach final state 2 from 1 by different paths here, and to reach from A to B either there are 3 paths are there, 1 2 3. Okay, either I want to move A1B, A2B or A3B. Okay, see here by checking the area, suppose A1B you have to take that area that is more than A to B with respect to initial state, final state, with respect to x axis. Okay, means therefore here we have to see that the curve, see that A3B, what is the curve? A1B, what is the curve? A2B, what is the curve? A3B, what is the curve? Check that. Is it the area under the each curve is different or same? By seeing that sketch, the area under each curve is different. Therefore, area under each curve is different means it depends on the path. Therefore, you have to conclude that, okay, area under the curve difference of work for each process means area different means it depends on the path. See here, area under the curve represents the work for each process because the for area for each curve is different. Okay, therefore it is evident that the amount of work involved in the each process is dependent only on the path followed. Whatever the path is there, that, okay, but not the end points. Not depends on the points A and B, but it depends on the path, that is 1 2 3, that is A1B, A2B, A3B. Okay, follow. Okay, we can observe that the area under each curve of process is different. Area under each curve here, A1 to A2B, check that area with respect to horizontal line, sorry, that horizontal x axis initial state and final state. A1B area is more than the A2B area. Okay, therefore area under each curve of process is different. Therefore you conclude that work is a path function. This is in general, work is a path function. Okay, that is first, what is that? Displacement work. Okay, next is what? Once displacement work is over, displacement work means how you have to find the work done, that is work done equal to in general PdV, pressure and volume, you have to write that. Okay, next, that is we have to write what is work, whether in exam show that work is a path function. Okay, for that here you have to draw the sketch PV diagram, pressure along y axis, volume along x axis, and mark that point A and B. For that you have to mark that path 1 2 3. Okay, mention that point number A initial state, point B as final states. The PV diagram as shown in figure. Okay, what happened? The check that area A1B and A2B, A3B. Check that is the area is same or different, because area is different by checking that volume. Okay, A1B volume, check that compared to A2B, the volume is different. Okay, therefore you have to say that work is a path function. Okay, this is the end of today. I hope that it is clear. If any doubt you can ask. In last class, that is the sign convention also you have to saw that is what is the sign convention for work and heat. That is remember that work done by the system is positive, work done on the system is negative, heat entering into the system is positive, heat leaving the system is negative. Okay, this is in general sign convention. Also, what is work, what is that is work, thermodynamic work, all things we have discussed. Okay, and this is the brief explanation. This is the sign convention. Okay, the displacement work, that is the piston arrangement. Okay, and the last one is what? This is the work is a path function. Okay, I hope that is clear. Thank you.